So let's see what we can do when we have one categorical and one numerical variable. Very typically, we're going to be interested in the differences in the numerical variable across different groups or categories or levels of the categorical variable. Say, for example, differences in price by neighborhoods. And so things that we can look into, differences in distribution, symmetricity, or maybe multimodality, things like that. Central tendency, the mean or the median. Are the prices on average higher or lower in certain neighborhoods? What about dispersion? Maybe the prices in one neighborhood vary a lot more than they do in the other neighborhoods. Those are the kind of things we might be interested in. And so, in terms of visualizations, we're going to see what we can do. Normally, things like box plots or histograms, but just reporting simple statistics many times is better. So, for example, reporting the average price by neighborhood in a table, it might be just what you need. You don't need to look into plots just because we can do plots. So in a histogram, we can just use, for example, different colors. And the idea is that room type, in this case, we have prices. So what are the three distributions of price by room type? And we see in red, we have entire homes, green for private rooms, blue for shared rooms. And we see that entire homes tend to be a little bit towards the right, so they are more pricey than private rooms, and their shared rooms tend to be the cheapest ones, which makes sense, right? But over here, we are comparing the distributions. And for instance, we see that in terms of dispersion, it looks like we have a wider variety of prices in the entire homes apartments, not so much in the shared rooms or private rooms, although we see some probably outliers in there. There's some blue points in there, so those are very expensive shared rooms. That might be telling us something. There's something else that we could do, which is a polygon plot, sometimes they're called. And they're basically just lines going through the tops of the bins. So for example, something like this one joining the green points. And why would be a good idea to make something like this? In case we have more than 3, 4, 5 categories, if we try to plot a histogram, there's going to be this bunch of colors all together. We are not really sure of what color is which and whether one distribution is here or there. So it might be just simpler to plot the lines, which represent the contour of the histograms, and that could be a better idea. It depends on how many categories you're comparing across. Of course, we can do density plots, and it's just like in the histogram, but because it's more smooth, it's smoother, it's nicer to see, it might be a better idea to visualize distributions. Again, with the pros and cons that we saw about densities as opposed to histograms. And something you're probably noticing here is that the shape of the blue density is a lot different from the shape of the blue histogram compared to the reds and greens. Now, why is that? What we have to remember here is that densities actually plot proper distribution functions. And what this means for the distribution function is that the area that we see over here in this shade of blue, it sums up to 1. So if you sum all the densities along the y-axis, you get 1. So the area in blue is 1 unit. So what this is telling us is that in total numbers, in the histogram, we don't see many shared rooms. They're just a tiny bit over there, just a few. But if we're interested in the actual shape of the shared room, regardless of the others, so what is the distribution looking like only for shared rooms, then we're looking here in blue. And we see that we have this big spike over here for low values. And the thing is that it's going to allow us to better compare what the shape of the distribution is across entire rooms, private rooms, and shared rooms, as opposed to just in the histogram, which is more telling us a story of what all the data set looks like. So we see that there are a lot more greens, a lot more reds than blues, but that's not really the shape. That's more or less the amount of observations. So depending on what you want to do, compare the shape over here or compare the actual numbers. you go for one or the other. So yeah, the difference is we are plotting here densities. Again, remember it sums up to 1, and here we have counts, so just raw numbers. And of course, we may be interested in looking into the box plot. So we have now one box plot per category of the categorical variable. And so what we see in this case is a quick comparison for central tendency and dispersion. What might be evident in here is that the average prices for entire homes are higher than for private rooms and shared rooms. We have a lot of outliers in private rooms. There's also a few outliers in shared room, which look kind of suspicious, right? This is a very pricey shared room over here. And we may see the symmetry of the distribution. So the distribution for shared rooms is a lot more symmetric than, for example, entire homes, etc., etc. And there's something interesting in the box plots, which are called the notches, which are these notches over here around the median. And we will see later on the course what they mean. They are confidence intervals around the median. But the important thing to know in the box plot is that they are somehow telling us how much error do we have in our measurement of the median. So assuming that this data set contains just a sample of data from the total population of listings in Berlin, this is telling us how much variation we have in the median just because of the sampling of listings. We will talk plenty about this later in the course, but it's important to notice here that in the box plots, we can actually plot these notches to quantify this random error. And of course, we could just do violin plots. And it's, doing the same thing, only showing these mirrored densities that sometimes are nicer than the box plots. Again, entirely up to you. The good thing about the box plots and violin plots in these situations is that we can sort the categories in the plot according to certain criteria, and that might be interesting for us to convey specific insights. So for example, on the left hand here, we have just a arbitrary ordering of the neighborhoods. But if we sort them by average price, then we have a better picture because it's telling us that the most expensive one on average is Pankov, followed by Mitterle, and then Charlottenburg, Treptow, etc., etc. And it's essentially the same plot, but it's giving us an extra piece of information by sorting the neighborhoods in this way.